Welcome to our lesson on properties. Make sure that anything that I'm writing down on my notes, you are also writing on your notes. All right, starting at the top, properties. Statements that are true for all numbers. So, in other words, we can take any of these properties and we can apply it to variables, numbers, etc. What you'll notice is that almost all of these vocabulary words, all of these properties, we already have in our notes, but this document will allow you to sort of review it and also to have it all in one place. So, commutative property of addition. It means the order in which numbers are added does not change the sum. So, for example, I could add 5 plus 6, and it would be the same answer as if I had added 6 plus 5. We can remember this because commute means to move. So in other words, I just move the numbers around, but it doesn't actually change the sum. Here's an example with algebraic expressions. X plus y is the same as y plus x. No matter what the numbers are, it will still be the same value. All right, commutative property of multiplication. Again, this is the same sort of thing. It means that the numbers, the order in which numbers are multiplied does not change the product. So, for example, if I multiply 3 times 7, that's going to be the same thing as if I had multiplied 7 times 3. Both are 21 no matter what. The other way to look at this is using algebraic symbols. If I multiply a times b, that will be the same as if I multiplied b times a. Now, the reason that I chose to write it out like this is because technically that's not the simplified version. We need to go alphabetical, but in this case I'm just saying a times b is the same as b times a, so it's okay to use the multiplication symbol right there. All right, associative property of addition. The way I think of associative property is you are associated with your friends or your group. So associative property has to do with grouping. The order in which numbers are grouped when added does not change the sum. So in other words, if I have something like 2 plus the quantity of 10 plus 1, that's going to be the exact same thing as if I group it differently. 2 plus 10 plus 1. Now, one thing that you'll need to notice here is that I didn't actually change the order of the numbers. This is a 2, a 10, and then a 1, a 2, a 10, and then a 1. But either way, no matter how we add it, it's going to be 13 on either side. What you'll notice is that this is similar for algebraic symbols as well. So, for example, I could add a plus the quantity of b plus c, or I could say the quantity of a plus b plus c. Sorry, I left my stylus at school, so I'm trying to fit in the box with my finger, but it's a little tricky. Next one up is associative property of multiplication. Again, I know that I hear the word associative, so I'm thinking of grouping. The order in which numbers are grouped when multiplied does not change the product. In other words, I can go ahead and regroup as long as it's all multiplication, and I will still get the same answer. So, for example, 3 times 7 times 2 is going to be the same as if I grouped 3 times 7 and then multiplied it by 2, because either way, my final product would be 42. Same thing if I were to do that with algebraic symbols. So, for example, A times the quantity BC is going to be the same exact answer if I had as if I had multiplied the quantity of AB times C. Now, the reason that these are the same is because all this is saying either way on both sides is A times B times C, ABC. All right, next property is the identity property of addition. Identity property is when 0 is added to any number, the sum is that number. In other words, I could add 5 plus 0 and it's going to be 5. I could add negative 1,000 plus 0 and it's still going to be negative 1,000. So anytime that you add 0, it's still the original number, which kind of makes me think of the word identity, because your identity is yourself. So you add 0 and it's still your original self. So for example, 4 plus 0 equals 4. Now the same thing happens when we use algebraic symbols. If I add a plus 0, it's going to equal a. Any number plus 0 is always itself. The identity property of multiplication is similar, but there is a little bit of a difference. We're not multiplying by the number 0, we're multiplying by the number 1 because, as it says right here, when any number is multiplied by 1, the product is the number. In other words, anything times 1 is still itself. So 3 times 1 is 3, or negative 17 times 1 is negative 17. So when we look at this with algebraic symbols, it's really important to remember that a times 1 would just be regular a. This is the most simplified version right here, just regular a, not 1a. So that being said, if you see something like 1a or 1x or 1z, you can really simplify that to be just the number itself. And again, the reason for that is because 1 times anything is going to still be itself. So it doesn't matter if a is 29 or if it's 37, 1 times whatever number it is, you're still going to have that same original number. All right, onward with our properties. Multiplicative property of 0. This one we have not talked about in class this year, but I do believe you probably know that it's that when any time that you multiply a number by 0, the product or answer is going to be 0. So if I have, let's say, 11.2 times 0, I'm going to get 0. No matter what it is, if it's positive, negative, fractions, decimals, you can multiply any number by 0 and the product is always going to be 0. That being said, x times 0 is going to be 0. And in addition to that, 0x really should be simplified to just be 0. And again, that's because anything times 0 is 0. Multiplicative property of negative 1. We talked a little bit about this property during our notes on distributive property. So it basically says that any number multiplied by negative 1 is the opposite of the original number. So I'm going to give you two examples here with regular numbers. 80 times negative 1 would be negative 80. Again, 80 and negative 80 are opposites. Now a second example would be if I were to start with a negative number, for example, negative 5. If I multiply negative 5 by negative 1, I'm going to get negative 5's opposite, which is 5. So again, anytime that you multiply a number by negative 1, it's just going to be the opposite of the original number. This is still true when we look at algebraic expressions. So, for example, x times negative 1, we could just say negative x, which again means negative 1x, but we don't need the 1 due to the previous property that we looked at, the identity property of multiplication. So make sure that you have that written down. Distributive property, we've spent a long time on distributive property, so you know it pretty well already, but just as a review, multiplication can distribute over a sum or a difference. So basically there's a number sitting out front, for example, 3, and there's either a sum or a difference. I'm going to use a sum because those are more common. Now, order of operations tells us we could add 4 plus 5, which is 9, and then multiply it by 3, which would be 27, but distributive property is also acceptable here. So if I go ahead and distribute this, it would be 3 times 4 plus 3 times 5. And what we would see is that we have 12 plus 15, which is still 27. So, order of operations tells us to do groupings first, but one way to get rid of the grouping would be using distributive property. So either way is fine. And of course, algebraically, we know that we could have an example such as 5 times the quantity of x plus 2. And all I need to do is go ahead and distribute. And it would simplify to be 5x plus 10. So again, multiplication can distribute over a sum or a difference, over addition or subtraction. All right, inverse property of addition. For every number A, there is an additive inverse, which we also called neutral pairs or zero pairs. So the additive inverse is the opposite of the original number. Any number plus its opposite is zero, and that's what the inverse property of addition states. So for example, 5 plus -5 is going to get you 0. An algebraic example of that would be x plus -x is going to equal 0. Anything plus its opposite is going to be 0, and that is the inverse property of addition. And our last property is the inverse property of multiplication. For every real number a, there is a multiplicative inverse 1 over a, such that a times 1 over a is 1. That sounds really complicated, but it's a fact that we already know. For example, 8 times its multiplicative inverse, 1/8, sorry about that multiplication sign, is going to equal 1. The trickier situation is when we move into variables. If I multiply x times 1 over x, I'm also going to get 1. Now, let's go back to the regular numbers example first to look at why this happens. If I were to make the first number an improper fraction, I see that I can cross-reduce here. And those both become 1s. So 1 times 1 is 1 over 1 times 1, which is 1. Here, I can do the same thing. And again, anything in itself can just cross-reduce to be 1, so that's how I get my answer as 1. All right, I hope you enjoyed our lesson on properties, and that's all for now. Thank you.